Welcome to School of Computing. In today's session, we will try to implement binary search tree. So we are going to talk about implementation of binary search tree. Implementation of BST. So before we implement a binary search tree, we know very well every node can have at most two children. So how do I represent a node in my C program? To create a node, what a node contains? Node contains three things. A node will look like this. It has got data and a pointer to the left child, pointer to the right child. So if there is no left child, it is null. If there is no right child, the pointer will be null. But if there exists a left and right child, then the pointers will be pointing to the nodes. For example, if there is a left child, then how the left child will look like? Again, the left child will also have a node which contains data followed by its left and right pointers. Same is the case on the right hand side. So I have a data component and left and right pointers. So what do you understand by this one? In order to implement a binary search tree, I need to create a node, and to create a node, I can't depend on the basic primary data types available in C language. I need to take help of a user-defined data type. How do we create a user-defined data type in C language? We do it with the help of structures. So I create a structure called as node, and in this I'll create three members, int, data, and two pointers of type struct node, because left child and right child are pointers which are pointing to left and right nodes, means I need a pointer of node type. So star left comma star right. This should be the structure, and initially I'll create a global variable called as root, and we store null in it, because initially the tree is empty, so we store null in it. Now on this particular node type, we will be implementing functions. So please do apply the concept of divide and conquer, means when you are dealing with a big program or a problem, you generally divide it into sub problems. So now what I am going to do is, I am going to divide my program into 4 sub problems. So first what I'll do is, I will define my node comma global variables and function declarations. Why function declaration? Because whenever you write user defined functions, you need to inform compiler, so function declarations. Then I'll create a menu using switch case, wherein I give options like insert, display and exit. To create a menu, I take help of switch case. So I'll define my menu in the main function. So I'll write my main function. Then I'll write code for my user defined functions. my insert function followed by display function. So this is the flow of the program. This is the flow of the program. Now look at the binary search tree program. As we have discussed the layout of the program, we will be following the same layout and we will try to understand the behavior of the code. So what is struct node? This part we have seen. It's a structure, it's a user defined data type. It has got data, one integer member and two pointers of node type left and right will be used to point to the left child and right child respectively. And I created a global variable called as root, which is initialized to null. So initially the root will be null. So since the tree is empty, root will be null. The reason why we made root as a global variable is I'll be using root in my insert as well as my display function. So in C language we know very well once a variable is defined inside a function it can't be accessed in any other function. And if you have some variables to be accessed in multiple functions then you have to make it global. And root is a variable which I want to use both in my insert function and display function. So I declare it as my global variable. These two are function declarations. Now look at the insert functions declaration or the function prototype. Insert function will take two parameters and it returns one parameter or one value called as struct node star. So what insert function is taking? Insert function is taking one struct node star means a pointer of node type as input along with one integer. The reason why we are passing these two inputs is insert function I'll give the current root node as input to insert function and also the value which I am trying to insert so that the value will be inserted properly by following the binary search tree rule. Means I need to decide whether the incoming element should become left child, right child, or is it the first node. Accordingly I need to insert. So I will pass the current root node and the value to be inserted as the inputs or parameters to insert function. And whenever the insertion is done, the tree structure will change, a new element gets added, and hence we will return the current or the latest root node once again as return value from insert function. So why we are returning in root node again? The reason is next time when we insert, we should be able to access the entire tree. So again the updated root or the latest root, current root will be passed. So insert functions parameter involves root and return value also involves root. Similarly, I have a display function in which I want to apply normal in order sequence to print the tree. And since to print the tree, I need to access the tree, I will be passing root node as parameter. So these are function declarations. Second part of my program, the main function, where I will be defining or where I will be creating my menu. To create the menu, I take help of two things. One is an infinite loop while of 1. The reason why I created an infinite loop is I wanted to give a menu to the user for insert, display and exit options. So as long as user is inserting, he can run the program again and again. And he can insert, he can display the tree in order sequence, and when user wants to terminate or quit the program, he will use the exit option. And till the user uses exit option, my program will continuously show the menu and user can perform insert and delete operation, display operations. If you want, you can even add the logic for deletion, and whenever a node gets deleted, appropriate pointer will be made null. Now look at the while loop. So I have three print statements printing the menu, and I am asking the user enter your choice, and user will type either 1, 2 or 3. That will be collected in a choice variable. Now look at the switch case. The choice variable is passed as input to the switch case, and in case 1 means insert option, right? So in case 1, we are asking user to enter the data because insert function, so obviously user will enter some data which will be collected using scanf in a variable called as val. I am calling insert function by passing root and val as parameters. Break is used to come out of the switch case 1, right? When user opted 1, only case 1 should run, it should not go to case 2. In case 2, it is display function. If root equal to null, tree is empty, so I don't want to print anything. Otherwise, then I'll call my display function, display of root. Case 3 is exit, and by any chance if user gives any other input apart from 1, 2, 3, it will fall into the default case where we will say invalid input or invalid choice. So this is my main function, second step, second part of my program. Now let us go to third part, which is my insert function. Now in the insert function, we are passing the root node and the value to be inserted as parameters. Now look at the first if condition, and struct node star new node. It's a variable used inside the insert function to store the newly created node. Now look at the if condition. If root equal to null, when this condition will be true, this condition will be true only once, when the first time a node is being inserted in the tree. So this condition will be true only once. If root equal to null, new node is equal to struct node malloc of size of struct node. You know very well the purpose of malloc. Malloc is used to do a memory allocation based on the size. So I am saying I want memory to be allotted for one node, and new node is a variable pointing to the newly created node, and the newly created node will have three components: data, left and right pointers. The value passed by the user is copied into the data part. Left and right pointers are null, and I am returning the address of newly created node to the caller function. If root is null, this is what is going to happen. Suppose I am doing an insert operation second time, then root will not be null because tree is not empty. So the first if condition will fail, and I'll come to this part. Let us say the second value which I am inserting is less than the root. Then obviously it should become the left child of the root. So what we are doing, if the value is less than root hyphen data, then I am inserting that value val. I am calling insert function again. So please observe this line number 77. If value is less than root hyphen data, we are calling insert function again, but where we are inserting that value? Root hyphen left we are inserting, means if the value is less than root, it should become left child. Similarly, if the value is greater than root, it should become the right child. I am calling insert function again, but the parameter is root hyphen right. So if you observe carefully, there is a recursive function called from insert function. Again I am calling insert function. So again insert function will be called, and I am accordingly, like if the value is less than root, it will go to root hyphen left. If the value is greater than root, it will go to root hyphen right. And one more condition, if the value is equal to root, the last else condition means if it is not less than root and not even greater than root, then what it could be? It will be equal to root, which is not allowed. So in a binary search tree, we don't allow duplicate values. So the last else condition, we write a single statement, duplicates not allowed. And finally, the last statement in the insert function is return root. So this is our insert function. The logic is pretty simple. We take an input and we decide where to insert it. If it is the first element, root equal to null, we create a new node. If it is not the first element, then we will see whether it is less than root or greater than root. Accordingly, we will call insert function again and again. And coming to the display part, struct node star root. I'm following the in order sequence to print the tree. If root not equal to null means if root equal to null, obviously I don't have anything to print. If it is not equal to null, we are calling the display function again. So it's a recursive call again, root hyphen left, then I'm printing the current data of the root, root hyphen data, then the last display function, root hyphen right. So if you observe the sequence, it is left, root, right, left, root, right. In this sequence, printing will be done. So this is the display function. Now let us execute and check the program. GCC binary search tree dot c hyphen o means output file need to be generated. So if you are running your program in VS Code, this is the procedure. The program got compiled and the output got generated in a BS out file. So I call that using dot slash BS out. So it is asking me, I'll try to maximize this window. Yeah, enter your choice, enter data, I am entering 30. Then again it is asking me enter your choice. 30 I have inserted, now I will insert 20. Then again it is asking me I will insert 100 now. So 30, 20, 100 I have inserted. Let me call the display function. 20, 30, 100. You know, in order sequence prints data in sorted order. So 30, 20, 100 was my input. 30 being the root element, 20 is the left child, 100 is the right child. So this is how a binary search tree program works. So this is the code. So I hope each and every line of the code is clear to you, and with practice and with the strategy of dividing your problem into sub problems, implementation of binary search tree becomes very easy. Not only binary search tree, implementation of any other program, complex program becomes simple if we can divide it into sub problems. So I hope implementation of BST is clear, and in the next session we will discuss the limitations of BST. Binary search tree seems to be good for searching because you find the smaller elements in the left side, bigger elements on the right side, that's all good. But still there are certain limitations in binary search tree. We will discuss the limitations of BST in the next session and we will see how it can be addressed. Thank you.